Good day to you, friends. Today, I want to make a demonstration of using strace to troubleshoot and also to learn about your system calls on a Linux operating system. First, what is a system call? In case you are not familiar what a system call is, or a system call is like an API that you make to the Linux kernel. So when you run a particular program or a particular process, or the process actually there are some operation that has to be done by the kernel or using system calls. So examples are fork system call, clone, execv. These are very popular system calls you should be familiar with. Next, what is strace? Strace is actually a command line utility that attaches to your process and intercepts and records the system calls and signals that your process makes. So these are the keywords there: intercept and record. So it intercepts and records all the system calls that takes place when you run a particular command. Or this command is great for troubleshooting. So if you're a professional, or it's great for students, if you want to learn about what our system calls actually takes place when you run a particular command, and even it's great for hackers. So what does this command help you to do? Like I said, you learn about your system calls, you can troubleshoot them, or you learn about what files are opened by your processes. You learn about, especially if you are curious about where your log files are going to, you know where exactly where the log files that your system is using. So let's go to the terminal. So system calls, the strace utility is actually available on, I think, virtually every Linux operating systems distros out there. So let me run ls. So I ran ls ordinarily, but let's say I want to find out what happens exactly. What happens when I run the ls command? I can know what happens by stracing ls. So I can type strace ls, and when I do that, you see it dumped some output on me. And let's look at the output. So the first one that come out is execv. Like I said, execv is a very important and very common and popular uh, system call. So you see it takes some parameters. So it takes actually the absolute path to the command. So rather than just taking ls, it takes the absolute path to ls. So it takes some other parameters, and you see the output is 0. So you see some other uh, system calls, like break, access, the memory map, fstat. So fstat is actually it takes statistics, get statistics of a particular file. So you see all the system calls, and at the end, where it actually writes out. When if I run ls again, so ordinarily it gave me output of dollar. So this is where it actually writes out. You see, the first argument is the file descriptor of the standard output, which is screen by default. That is file descriptor 1. This is the data that was written out, and it told us it wrote 5 characters or 5 bytes. So you see 5 bytes, which is true. So this is how to run a system call ordinarily, but this is not the only way. The options are available actually that make it even more useful. So we can use options. So the first option that I will introduce is -o. -o is, it gives you ability to write the output to a file. So let's say we call this out st.out. So okay, that doesn't go out. Oh, actually, sorry about that. I have to put things here -o st.out. Oh, let me clear my screen so that that can become clearer. So you see, so now it created a file called st.out for us. So we can look at the content of st.out. So the content is the same thing as what was dumped on the standard output earlier. So that is one option, very important if you need to save your output. Another option that I will introduce to you is -e. -e is actually very important. The -e allows you to strace a particular call. So let's say we want to actually see the write, where it actually when it actually writes out to the standard screen. So, or let's say we just want to see any write system call that takes place. So you see, the only write system call that takes place is the write, and you see the standard the file descriptor 1, and you see the these are what is going to write out, and you see it told us it wrote 13 byte out. So you can extrace a particular system call. So let's try another one. Let's see, want to see open. Want to see every open system call that takes place, and we see there were a lot of open, but some of them refers to some shared libraries, and another open to proc file systems. So basically, and okay, it's okay. I think this is the crucial one here. You see open to, so you see this is dot here, or period, refers to the present directory that we are in. That is the present directory. Dot, you see, when if you type cd dot, it doesn't go anywhere. It means what is the present directory that we are in. So you see, it opened the present directory and read what is inside that directory. So you see, we can actually understand what ls does. So let's move ahead. We can strace and look for a particular file. Let's say want to look at or want to trace to a particular file. So let me use another command. Let me use something like dig. So if you're not familiar with dig command is ordinarily, let's say I want to get the IP address of yahoo.com. So if you're not familiar with dig command, this is what it does. It helps you to do some DNS query or resolving hostname to IP address. So let's strace dig strace dig yahoo.com. So it's give us a lot of output again. So if we go to the beginning of it, again we see the execve. Now you see it has to take the absolute path to dig, then the other parameters that we give to dig. You see, so if you want to learn about execve, this is actually a great way. So, and it gave us a lot of output. But let's say we want to strace dig, but we want to look at open, where it opened a particular file. We want to see where it opened etc resolve.conf. We all know x, and if you don't know, etc results conform .conf stores information about your name servers. Sorry about that. Strace. Okay, maybe it can go that far. Let me quote it and see. Oh, okay. I think, yeah, it's supposed to be able to go take a file, but let's I will show you how you can do this again. But let's say want to see it's a great way to look at another system call. Actually, I will come back to the or how to look for a particular file. So we can trace our sockets. So if you are not familiar with sockets, so this is this strace about information about the sockets that were created when we did dig.com. So 3 sockets were actually created. There was one socket stream, there were 2 socket streams actually, and well, all of them are sock stream, which is TCP if you are not familiar with that. Then the socket family, that's the first argument parameter. The last is the type. So the type is, so this is IP proto, this is, that means this of IP type. So let's look at another option actually. Okay, another option is the verbose option. Let's say want to get more information, or let's trace our ls again, but now with more verbose. So I don't think this gave us a lot more verbosity, but the -v is okay. Let's remove the expression. So we'll see it gave us a little bit of more details, especially, yeah, okay, this is actually a very good thing. So look at exec v now when we run it with more verbosity. So apart from taking the absolute part and taking ls, we also see another thing that it took was actually the environment variables. So you see all these things are environment variables. So this is actually where your environment variable becomes important. So if you are running a command and you want to know what are the variables this command or process is using, this is the perfect way. So, or if you passed a particular variable and you want to find out if it's being used or not, this is a perfect way to do this. So let's move ahead. Let's look at another option. Another option is f-f for follow. So I hope you are keeping. I hope you are following, because this is a very important things. So let's look at -f. With -f, you can follow. What follow means, you follow a particular process and the child processes. So if a particular process creates another process, you want to follow those child processes also. So on this system, I actually have our bash. So I'm running I want to grep for bash. So I grep for bash. So this is my bash process actually, and the process ID is 3339. So I want to attach to my bash process and follow it. So I'm going to do that. I'm going to open a new terminal. I'm on the same system, but I have 2 terminals. So I want to strace, I want to follow, but let me quickly introduce to another option, p-p, which stands for the process ID. The process ID is, for example, is the process, the 3339, which is the process ID for bash, for this bash here. So I want to attach to it and run a command. So if I attach to it, you see, I know exactly what my bash process is doing. It is waiting to read from the terminal. So let's go and give it something to read. I can type ls, you see, so ls and press enter. You see, we're able to attach to it and follow it. So see, you see it's read from the standard input. You see, the standard input is file descriptor 0. It read ls. If you can read this is actually ls. So it read ls from the terminal, and it cloned, like I mentioned to you, it cloned a new it cloned a new process, which is a child process, and we're able to follow that process. So this is a result of following the ls process. We followed it, so using the dash f. So this we can see how. So if you want to attach to a running process, this is what dash p is for. So if you have a running process, you can attach to it with dash p and the process id, and follow the child processes that might be created. So this is a cool stuff. I hope you can get to it, and if you practice a couple of examples, you are going to be able to understand it better. So let's look at another option. Another option is dash c. Dash c is for count, but dash c, usually we use it with dash w, and it gives us a statistics. So let's do that. Let's do a strace again. In this case, we use dash c and dash w. You see the output. It gave us all the system calls that happened during this process, during running ls, and it told us the time that each system call, like the total number of time that this system call was running, and it told us the number of calls. So that means the mmap was called uh 17 times. The number of microseconds per call is 24, and the total time is 18.74. So we can know the total time that was used in calling a particular system call. If you want to troubleshoot, you want to know where your process or your command is spending the most times. This is a good way. Let's move ahead. Okay, I've talked about dash c, dash w. I've talked about dash p. Actually, you can attach to a running process. So let's talk about dash uppercase p. Dash uppercase p can be used to know to know if a process uses a particular file. I think maybe that was what I should have used the other time. Yeah. So I want to know if my command uses the file etc resolve.conf, and yes, it did. So you see, it told me that there's an open that was run on the resolve.conf, and the result is a file descriptor number 6. Then there was a start, f start that was done on this particular file. You can see the file descriptor is still 6, and there was actually some things that were read from it. So you see, that means this dig command looked at my resolve.conf to know what my name server is. Let me do one more demo of this. Let me introduce another. Let's do with another command actually. I have a web server running on here. So let me run the call. So I run the call on this my web server. My web server is running on 10.0.0.100. Takes some time. Yeah, so you see, I said $stack is here. That is the output of this call. So I can strace this command and use an expression, and I want to see write. I want to see where it actually writes out. You see, this is where it actually writes out. You see, it says write the file script descriptor number one. This is what it wrote out. It wrote out 19 bytes. So that is a great way. Or let's look at maybe there was any socket, and we can combine. Actually, we can combine system calls here. Let's combine socket with open with send message. So you see, it gave us a lot of output. So let's reduce this actually a little bit. Let's remove open for now. Let's just let's use socket and send. Okay, maybe there was no send. So you see, this is where it created two sockets. Actually, it created one of them, or IPv6. You see, this is the address family, IPv6 sock diagram. So if you're not familiar, this is UDP actually, and the second one is IPv4 and sock extreme. This is TCP if you're not familiar with that. So you see how we are able to find out what our processes are doing. We're able to use the uppercase to know if a particular process is using a file, or by using the -p. We were able to look at a couple of system calls. We can play around again. Let's say I do my ls. I want to remove this file st.out. So let me remove st.out, and let's strace it. So we strace it, and let's see what happened when we did this remove. We see at the end here, the command that was actually used to remove my file is unlink heart. Unlink. So you see, unlink heart. It gave some variables and the name of the file that I want to remove. So you see how I can know what exact command is, what exact system call was called to remove my file. Like I said, the execv is a good way. We can let me actually just run this st. I'm creating this st.out again. Let's run the remove again. So let me create a dummy variable. I'll call it var_d equals $. You see, I'm stracing, then I'm creating a variable. So let me use the variables actually with strace. I want to see okay, that's not there. I want to see how to combine setting a variable on the same line. If you're not familiar with that, let's see, var_d equals $. Let's see. Okay, it didn't take it. So, okay. Yeah, that's fine. Or let me just use the export for now. Export var_d equals $. Then let's do variables. So let's look at execve again. So if you look at execve, the variable that I created, as you can see, the variable that I created is here. So part of what is passed to execve is the environment variables that are available. So I think this is enough for this video. I've gone over a couple of examples. You can watch this video again, or if maybe I lost you somewhere, As you know, this is a live demo, so at times maybe things don't exactly work the first time, but you can see everything work finally. But um, you can watch it again so that if you don't get something, you'll be able to understand again. But and also you can look at the man pages. The man pages is actually very informative about what you can use this command for. Let's go down. Okay, yeah, basically just described this command and give you other options that may be available. So thank you for watching this video. If you have a comment or a question, you can leave them in the comment section so that we can talk about it. So thank you. I'll see you in some other videos. Bye.